Nice to be back here in Oslo. I've been here a few times, yes, so maybe some of you recognize me. So I am from Byggstyrning. We are a construction management consultancy company in Sweden. We are a small company, only 12 employees, but we help big facility owners with their project deliveries. So we help building owners from early phase to the end of the project. And we have mainly focused on office buildings in Stockholm and Uppsala. And worked a lot with Vasakronan with their big office development they had. And my role in the projects are usually to be like the head of all the digital tools we are using, but I'm also helping with as a design manager and yeah, everything that's needs to be done. And I'm going to talk about how we have been delivering digital 3D rebar and into the production, and actually have not been using any rebar drawings in our latest projects. And this is not like all the credit shouldn't be to me, because we have had amazing support from our structural engineer Victor and the site manager Kalle and the supervisor from the concrete subcontractor Patrick. But since there is a national holiday in Sweden, all the kids are off from school, so they could not come here. Otherwise Victor would come here and talk about this as well. So they know all the nerdy details about rebar. I have just helped them to fulfill their dream about using 3D rebar in production. So the project is a big renovation project in central Stockholm. It is in the middle of the center of Stockholm in Tureplan, so it's a really busy place, and it's an old building that's completely renovated. We tear down everything inside and added one floor as well. So it's some new construction as well. So the building is from 1942. Some part of it from foundation or from the 18th centuries, sometimes long ago. And the production is finished. It's a finished product. The development is the tenant is moved in last summer. So we have all the results and everything is done in this project. So I had a little fun with Johannes Ris from TCAB some time ago. He wanted to test his FPS. Oh, I didn't know it was some music here. Can do that. So he wanted to test his FPV drone inside our construction. So there is Johan controlling the drone. Here we have tear down the top floor and started to add the new one. And there's me showing him, guiding him through the window. So you can see we have completely removed everything inside, all the installations. Some part of the structure we had to replace as well. So we had to demolish big holes through the whole buildings, some places. And inside you see we have completely removed a lot of the floors to refit the floor to be more suitable for office. There were a lot of levels before. So we've done a lot of demolition inside here. So we need to add a lot of material here and a lot of old structures that we need to connect to. But still, we have done this as a total BIM project. So still we have the 3D model as our legal construction contractual document. So even though we have a lot of existing structures and a lot of unknown and a lot of weird things in this building before we start to work with it, we still have the mindset that we use the 3D model as our contract document. And I added a slide here because we talked a lot about mindset and how we should work support this way of working, and I think that is something that I can really speak up to. And I wanted to add some pictures that I love to take pictures of people on site when they are engaging in discussion and like helping each other. So here we see Kalle, and you see the electrical guy. He holds his iPad, and they are discussing something that he cannot fit there. And Kalle is like, "But you have this tolerance. You can absolutely put that there, because with Total BIM we put in so much detail. We narrow things down, and we try to we make it work, both in the model, then it should work in the reality. But they are not used to this high level of tolerance when they are installing things. So they want to cheat and like, no, that cannot be done." And you see also here, Sebastian is also out there helping the people with asking questions and answer. And that's a big thing about using digital tools, and especially 3D Model and like digital, all the administrative work on a construction site, is that these guys, the supervisors, the site managers, everybody, they can spend more time on site helping the production on site, because they can manage everything that they need to do through their phones. They can like do everything from their phone on StreamBIM. We have all the communication, everything, so that they can be outside on site and not sit at meetings or writing meeting notes or something like desk work. They love to be out on production, and we want to keep them out on the production site as much as possible so they can talk to people and help them move forward with all problems. Another thing to help like improve the work environment, we started to put up like a welcome control command center when you enter our building sites. We have a screen that shows if there are any reported safety issues on site. We have a StreamBIM workflow that everybody can add safety issues in, and we can react them. And if there's something bad that we have spotted, the light is red, and then everybody that works into the site sees that, oh, it's red, now we need to act on something. Or if there is a safety issue that we added, like that, oh, you can fix this during the day, it's okay. But then nobody has fixed it during that day, then it turns red the next day. So it's to keep people aware of safety issues and help each other out about having a safe environment on the work site. And some other screens for logistics and tax planning and stuff like that. Yeah, so there was just some slides I drew in. No. So how do we do Total BIM in a big renovation? I will come to the digital rebar in a minute, but I need to explain just how we managed to have the 3D model in this stage. Because when we got the project, we started to just we made a simple BIM model from the old drawings from the 30s. Because we couldn't access the building, it was still rented out. And then we got to level 2 when we got access to the site, the building. We laser scanned everything, and then we could enhance the model even more. And then when we started to demolish things, we figure things out. We go to BIM level 3 when we really need the details of the. We need very good precision in some part. Then we laser scan it. We put it in Immerso to really see what we have modeled and see if we could fix anything. So this is from an old elevator shaft that is 100 years old, and we're going to put a new elevator there because there's new regulations, but we cannot do anything with the existing stair. So we needed to know exactly how big that elevator could be to fit there. So we needed extreme precision in some part of the building. Then we added that later on when we could access that area. demolish the old elevator. Yeah, and the engineers could enhance the precision in that part. And that we did throughout the project where we needed, when we got access to different parts. So we constantly had a laser scanner available to do this kind of work throughout the project. And also discover things like this where you see this, you don't see that? You see this steel beam, old steel beam. Usually in the drawings they were like CC 150 everywhere, but in reality it was 150 here and 180 down here, so it was really weird. And we were going to take up new shaft here to install all the new systems, and so we knew that we have to know the locations of all the shafts quickly. So quickly we got access to the site, we could start investigating things like this and discover this. We can move all the installations a bit instead of like discover this when we actually were there taking up that hole. To really investigate through and enhance the model to find things early, we did a lot to not stop the production. So find problems ahead of time. And then we had total beam for the demolish part as well. So we 3D modeled the whole structure, including all the roof trusses, and so we could have the demolish company also be having a contractual IFC model that this is what you are going to demolish. We could get extremely well quantities from this and that it was clear for them when they were outside demolishing things. They had an iPad that you're going to cut this wall here and this is going to be removed, and we could control the demolition very precisely with having that also in the pretty model. So it was a pretty rough environment during some time, because we demolished a lot and we needed to add new structure as we demolished, because we were removing support structures. We need to add temporary support structures. So it was a lot of building and demolishing at the same time, but we still managed to keep a really good environment inside, and this was all planned, so we could really like go on in a nice way. It was not like panic at any time, because everything we had planned ahead of time. Yeah, so now to the rebar and how we managed to do 3D rebar with our drawings in a project where there are so much uncertainty and new things. It's not a new development. It's not like you're putting up a wall on a green field. So I'm also going to do a little live demo. But before I do that, I want to explain the basics of how we got on this, because it's to be able to do this, like Johan also was talking about, we need to be able on site to filter out what we want to see, and because there are a lot of different things that you want to view. So we had a lot of talk with the concrete workers and the supervisor Patrick. What do they need on site to be able to build this only from 3D model? And then Victor, the engineer, we put up a piece set for rebar, where we collected all the important rebar properties that were needed so that they could filter this on site. So each rebar is coded in different ways to be able to filter on site later on. So that's what I'm going to show now, if everything works according. Yeah. Okay, so this is the building, and we're gonna show you all these horrible layers. And if I only look at all the concrete work, we have this much concrete work that is going to be done in the builders. So it's mainly down here we needed to add new floors. The other floors we built in wood instead because have lower CO2. But this floor was not possible to have wood on with. And if I turn on the rebar, we have a lot of rebar as well in all this concrete. And if I click on a rebar and now filter on one of the key parameters that were needed were like proper construction part. So the engineers coded the different parts, or maybe I should color on it instead. So now all these different colors are different construction parts. So we divided all the structures in different parts that they were going to build in sequence, so they can focus on only this beam and only this beam and this beam and so on. So we could filter out exactly for that building part. So narrow it down. So I'm going to show you an example on that here. So the way we approached this was to show that first. We have the concrete foreman that were sitting and planning all the works. He created a work order with there was a topic in StreamBIM that now we're going to build this building, this beam or this to the floor slab. Then he created a topic in StreamBIM, added that as a work order in their folder, and then he created like a material takeoff of that, or a list of material that we needed to order, and planning the work with the workers, and then so that the workers could just then go out on site, take up their phone, go to that topic, and then read and start work from that, and then they added information about progress in that topic in forms of photos and so on. And the engineers also had access to this work order, so they could also follow the work and they could answer questions from the workers inside that topic. Because since there is a renovation project, a lot of weird things happens on site when they start doing things. No, we cannot put that rebar into the wall here. Can we put it here instead? They phone and ask, and then the engineers can just update that topic really quickly. Yeah, so I'm going to show that now. So here we have that work order. It's just a topic, and oops. So the foreman just showed this is the part that we're going to build. Then so it's this one, and usually we don't need to explain that much because they talk to each other and about what they're going to do. So the workers know the first thing that they are going to do is to build a form for that place. So what they usually do is just make a section and just measure on their phones on site how high we need to build a form. So that's the first thing they check and do, and they can measure this on site. They don't need to like have any more information like this to build a form for this slabs. So after they built the form, Patrick, the supervisor, orders all the rebar, and all the rebars come from a specification from the model. So we have all the rebar here. So if I click on one rebar in this building part and filter on this construction part, now filter all the rebar in just this building part. I can also filter on schedule mark. I'm not a concrete engineer, but this is the different type of rebar types there is in this, so they can have them colored and they can see how many of each type there is. They can also control if we have any rebar with different size. We see that we have one 10 millimeter, we have most 10 millimeters, and then we have 60 millimeters as well around here. So they can themselves look for filter and color and understanding what they are going to do. But then from the model, the structural engineer creates a rebar specification. So the rebar is ordered, and we have like the list of the rebar put here. And then basically they just start work and create photos along they go on specific areas they want to highlight, and just add pictures for showing how the progress is doing. And some information about what the next step is, and some photos. And then they pour the concrete here, and they add all the different recipes of the concrete mix that came to the site. They get a recipe for that. They put that in the same work order here, and they have a quality checklist. We can do this like digital in StreamBIM as well, but they wanted just a simple checklist like this. I can't fight for everything. Next time. So we have all the information here about how they did it, and yeah, so that's for that. And I can show you where we need some details, because so we had no rebar drawing to that, but we have some places where we needed some, not rebar drawings, but rebar information that is hard to put in 3D that we want to put, we need to inform anyway. See if I manage to find that. I think we have some in these. Oh no, there was a beam. It should be the beam. Back up. Get over here. Yeah, so we just have a lot of work orders, different sort of things. Okay, maybe I have it linked to the PowerPoint. But even the smaller parts, in the building there was a lot of removing other old brickworks and replace with we needed to poured concrete here over some old structural thing that came up during the demolishing. So here is also important where we put all the rebar in the right place here. So we can do the same thing for this building part. We can filter it out. We can see what kind of rebar we have. And it's easy for the concrete workers to actually build from this. And the same thing here. They documented with photos. And this is the result. So it was more like, here we need some concrete work, create 3D rebar, educate the construction crew on how to use StreamBIM, educate the supervisor how to use StreamBIM to create like this work order thing through topics, and off they go. So we had, as I said, we had some. I need to find. Must be in this one. But I wanted to show you if anybody here maybe have some good idea how to solve this. Yeah, like sometimes we need to explain things anyway, and in this work order we can create like very simple illustrations on how to solve things that occur. So this is something that happened, like they discover something, can we do something else? Then we can, the engineers and everybody can be involved and quickly like find a solution so they can move forward. And this is an example of not a rebar drawing, but more on instruction to the concrete crew on how to go on in certain details, because maybe this is hard to explain in a 3D model, all these details, how they're going to put some special material here and do something there, and also all this rebar that needs to be in two steps that are going to be bent down in the next step. How do you 3D model that? Then you need one that is like that and one like this. How do you explain that they're going to do that? We have not figured that out. So that is something that we needed to show like this. But there are no measurements here or anything. It's just explaining the steps how to go on with certain situation. But our engineer Victor he's like really I want to get rid of these as well, because he really hates doing rebar drawings, but he loves doing them in 3D. So when I talked to them after the project, I asked Victor if he was happy with the way they worked, and if it were for his engineering company, they have all this internal structural how to deliver rebar and stuff. But Victor was certain after this project that it saved a lot of time for the engineers with not creating rebar drawings for all this. And as I said, he wanted to push it even further. This was 2022, and he believes that you can do even more advanced 3D modeling stuff. Maybe we can animate an IFC rebar. So, and that we didn't start with this building part structure. We added that later on. So that was his. He wanted really to emphasize that if you're going to do this, try to break down the elephant in smaller parts and focus on building parts and create work package around building parts. And Patrick, the concrete supervisor, he was a bit skeptical in the beginning, but so he almost had to learn to ride that bike with steering wheel at the wrong. But he also started to really like this way of working, because he could document everything more efficiently. It was less administrative work for him, and he could do quantities and find issues early on. And he admitted that if we had goings on this project, we would run into so many problems because they would be outdated so fast, because when we started to work, things changes. We need to have a new rebar going from the engineer. That will take a lot of time. Now they could just talk and they can quickly update the 3D model. And we have a script that runs every night to update StreamBIM. So we have really fresh models. Freshly served models every day. But yeah, in the end he was happy after we got to do everything. But he said that in a renovation project, maybe you should not prefabricate as much rebar because of all these changes. So his suggestion was that order more length and bend on site rather than so be selective on what you prefabricate, because in the end we had to change a lot of things, and we had already ordered a lot of rebar to the site. But at least he was happy in the end, and he finished every work on time. And overall, the project was actually a big success. Now I just talked a little bit about the rebar, but we have this total BIM philosophy in all the processes in this project. And the project was finished on time, it was finished on budget. We have a low CO2. We used a lot of things in the project. And we used the Rufus and other systems to track inventory and stuff like that. We completely changed the installation systems, so we have extremely low energy consumption in this kind of old building where we're not allowed to do anything with the facade because it was highly. We were not allowed to touch anything with the facade or the. So even though, like, the energy is going through the facade, we still have very low consumption. So we actually won the best construction project in Sweden this year, an award, a nerdy award. And we also won a prize for best on-site safety award, the innovation with the traffic lights and the awareness of everybody keeping up with the safety on the site. And we also won an award for best project culture and best project quality, where they measure how well the organization is doing and performing. So a nice prize for us project leaders. So when everybody's happy, everything works. Yeah, I'm going to let you have a break really soon. I just want to show you what, because that is old stuff. I want to quickly show you what we have been up to this year, because we have gone deep into creating a lot of add-ons to StreamBIM. This is a widget we have created for our next project. I am not allowed to show you how it looks yet. It will be revealed in January, but it's the Noble Center in Stockholm. And the client and the architect wanted to know how the building would look in the context of Stockholm, and how from the boardroom, what view would you have. And you can do that in a lot of complicated visualization software, but we throw in that engine into StreamBIM, so you can actually navigate in real world context and look out from windows what you see within StreamBIM. That was something fun. And also, we've been doing a lot of, since we have a lot of advanced workflows behind this, a lot of things can break. So this is just a dashboard to track how our system is doing, because we have a Revit environment that we export from every night, and then we have a process pipeline that we built that's doing stuff with IC files, and then we push them into StreamBIM. And along all these steps, a lot of things can happen, and then the project is angry. So here we can trap what happens through if everything went well with export in Revit this night. Yes, we started at 11 last night. We process it from, we do a lot of things with IFC after, and then they end up in StreamBIM, and everything went well here as well. These are not supposed to be updated, so it's okay. And the architect, we have frozen the design, so it is also okay. That's why everything is green here. But here we can see what happens. We can check the health inside the models, what is going on, if anybody has any problems. Here we have our clash matrix that we do every night between all the RFC files to see what overview of all the errors. And here is what happened on the StreamBIM server when we would process things. So here we can monitor our processing pipeline. That is just a fun thing I want to show you. Now let's take a break.